Honda Civic radiators just cooled a Bugatti Chiron W16 engine. Not as a temporary fix, not as a rough approximation, as a fully functional, tested replacement for components that Bugatti refused to supply, confirmed working at operating temperature. 92 degrees Celsius. Fans on. Temperature held. Honda Civic cores. In a £3 million Bugatti. And here's the thing that most people watching Matt's video felt but didn't fully understand. That reading wasn't just confirmation that the radiators worked. It was the answer to a question that had been sitting unanswered for 14 months. Ever since Alex drove this car without coolant. By the end of this video, I'm going to tell you exactly what that temperature gauge was measuring, why Honda Civic cores were actually the right engineering choice, and the specific moment during the test where everything could have gone wrong, and didn't. But first, the part nobody explained. Why did Bugatti's radiators cost so much, and how did a Honda Civic replace them? Bugatti refused to supply replacement radiators for this car. 10 separate radiator assemblies were destroyed in the crash, all of them essential for the W16 to run at operating temperature. If Bugatti had supplied them, the cost would have followed their standard parts pricing model. The same model that quoted £300,000 to fix a gearbox fault that turned out to be a £5 fuse. So Bob sourced Honda Civic radiator cores instead. Not a Civic Type R. Not a performance variant. A base model Honda Civic. The kind of car that costs around £12,000 new, gets 40 miles to the gallon, and is bought by people who need reliable transport at a sensible price. And here is what most people watching the video missed entirely. The cores weren't a compromise. Bob visited PMA Automotive Cooling, a radiator manufacturer in the UK. He walked through the factory, learned how radiator cores are built, and identified cores that matched the Chiron specification. The Chiron's original cores had 75 fins per unit. The Honda Civic cores Bob sourced had 73, but the fins were slightly larger. Same total surface area. Same heat transfer capacity. A different physical configuration producing the same functional result. That distinction, same function, different configuration, is the entire engineering story of this rebuild compressed into a single comparison. Bugatti's parts aren't expensive because of exotic materials or secret engineering. They're expensive because Bugatti controls who can buy them. Bob found the same engineering in a Honda Civic parts catalog. Now I'm going to tell you what happened when those cores were tested at full operating temperature, because the story isn't as simple as, it passed. The W16 was started. Coolant began circulating through the system. The temperature gauge, displayed in Fahrenheit because the Chiron's dashboard offers no Celsius option, began climbing. Cold start. The temperature rose through 90, 100, 150 degrees Fahrenheit. At this point, the thermostat was still closed. Coolant was circulating only through the small internal engine loop. The radiators weren't in the circuit yet. What Matt was watching was engine-side coolant temperature only. Then the thermostat opened. This is the moment everything Bob built was actually tested. When the thermostat opens, the full cooling circuit activates. All 10 radiators come online simultaneously. Hot engine coolant reaches the radiator cores for the first time. The aluminum end tanks Bob fabricated from sheet metal are exposed to their full thermal load. The temperature continued rising. 194 Fahrenheit, 90 Celsius, the target. Then 197, 199, 201. Matt's voice in the video at this point. The fans are on. Come on, cool down. He was watching the thermostat work. Watching the temperature try to stabilize. Watching Bob's radiators respond to their first real thermal load. 201 Fahrenheit is 94 Celsius. Just above the operating target. Fans running at full speed, pulling air through all 10 radiator cores. Then the temperature dropped. 199, 198, 192, stable. And here's why that specific behavior, rising slightly above the target before dropping back, is actually the correct response. Every engine cooling system overshoots slightly on its first full warm-up cycle. This is normal. It's expected. It's engineered. When the thermostat opens and the full radiator circuit activates, the cold coolant sitting in the radiators mixes suddenly with the hot engine coolant. The system hasn't yet found its equilibrium. The fans activate at maximum speed. The temperature drops. Then the system reaches its operating point. The thermostat modulates, the fans cycle, and the temperature stabilizes. For Bob's radiators, the overshoot to 94 Celsius before dropping back to 92 is textbook correct behavior. If the radiators were underperforming, if the fin density was insufficient, or the end tank volume was wrong, the temperature would not have dropped back after the overshoot. It would have kept climbing. The fans would not have been able to remove heat fast enough. The temperature dropped back. That means Bob's specific engineering decision, 73 slightly larger fins versus the original 75 smaller fins, produced heat transfer that was equivalent to, or better than, the Bugatti original. Here's the part Matt said on camera, and the part that reveals how much uncertainty had been sitting over this entire rebuild. I'm hoping everything works, because Alex drove this car without coolant. That sentence carried 14 months of uncertainty. And the temperature test was the moment it was either resolved or confirmed as a problem. The Bugatti Chiron has multiple water pumps. Each pump has a shaft seal, a component designed to run permanently wet, with coolant lubricating the seal material and keeping it within its operating temperature range. When Alex drove the car without coolant, those seals ran dry. The heat built up. The seal material degraded to an unknown degree. A compromised water pump seal doesn't always fail immediately. It can hold under cold conditions. It can hold through brief warm-up cycles. The failure reveals itself under sustained operation at full temperature, which is exactly what the temperature test was. When the temperature stabilized at 92 degrees Celsius and held there, every water pump seal in the system was running under its full design load for the first time since the crash. Then the dipstick came out clean. No milky discoloration. No coolant in the oil. No sign of seal failure. The seals held. Matt made the comparison on his second channel, the Huracan reference. A previous build where the water pump seals were destroyed by a no coolant drive. That comparison wasn't casual. It was the benchmark against which this result was being measured. The Chiron's seals survived where the Huracan's hadn't, possibly because Alex's drive was brief. Possibly because the Chiron seals are more robust, possibly because the specific conditions of that early test didn't generate enough heat to destroy the seal material. Whatever the reason, the seals held. The temperature test confirmed it. There's one more thing the temperature test confirmed, and almost nobody is talking about it. At 3 in the morning, after the coolant leaked from a newly modified bracket, after Matt's TIG welding attempt had failed, after Bob came back and fixed it, the coolant went into the system by vacuum fill. 39 liters, pulled in by negative pressure through a system with 10 separate radiators, multiple circuits, and numerous high points where air could be trapped. Air in a cooling system is dangerous. An air pocket at a high point creates a section of the circuit where heat can't transfer. The metal in that area heats unchecked. In a system as complex as the W16, 10 radiators, multiple pump circuits, an air pocket in the wrong location can cause a localized temperature spike before any warning system responds. The temperature test at sustained operating temperature, with the thermostat open and all 10 radiators fully active, was the first real confirmation that the 3 AM vacuum fill had been complete. No air pockets. No localized hot spots. No unexpected temperature spikes anywhere in the circuit. The fill worked. So here is the complete picture of what that single reading, 92 degrees Celsius, fans on, temperature held, actually confirmed. Bob's radiator cores are thermally equivalent to the Bugatti originals. The water pump seals survived Alex's no coolant drive. The vacuum fill at 3 in the morning was complete. The cooling circuit that Bob and Matt assembled, with Honda Civic cores, fabricated aluminum end tanks, and a vacuum filler they nicknamed Mrs. Suck, functions correctly as a system. In one number on a diagnostic screen. Bugatti's parts monopoly depends on one thing, the belief that their components cannot be replicated by anyone outside their supply chain. That belief, held by every Bugatti owner who has ever paid a parts invoice without questioning it, just took a significant and permanent hit. Not because Matt claimed the Honda Civic cores would work. Because the temperature gauge confirmed it. At operating temperature. Under load. In the actual car. That confirmation is now on YouTube. It's time-stamped. It's searchable by any Bugatti owner who wants to know whether the parts they've been told are irreplaceable actually are. And Bugatti cannot delete it, because 92 degrees Celsius doesn't lie. Bob didn't just build replacement radiators. He built evidence. For every future Bugatti owner who needs radiators. For every technician who quotes for them. For every journalist who writes about manufacturer parts monopolies. There is now a reference point in the public record. Honda Civic cores, correctly specified, correctly fabricated, 92 degrees Celsius. The evidence is permanent, free to access, and the manufacturer who refused to supply the parts has no mechanism to remove it. Subscribe because the radiators passed. The first drive happened. The finish line is close. And 92 degrees Celsius is the most expensive temperature reading Bugatti has ever witnessed.